This is a demo for a class example for VBA. So let's start with question 1. So question 1 would ask us to create a pretty simple user-defined function called add1. So that if we input 4 here, the output will be 4 plus 1, which is 5. And if the input is 100 here, then the output here will be 100 plus 1, that will be 101. So how to build this user-defined function, we can actually refer back to the class example, so which is this one. This is called plus. And we can just simply modify it based on this example. So first open VBA. Then I'll start writing the code for question 1. So then I'll change the name to add1. And we only need one parameter here. So add1 here equals parameter 1 plus 1. It looks pretty good here. Then I'll just go back, equals add1. So now that we've completed question 1. So then let's go to question 2. So the requirement of question 2 is in the lecture slides, which is here. So basically, the banks offers different interest rate, and our input is actually the deposit, and we'll see whether this amount of deposits fall in what range of the interest rate. So interest rate have different level, and depending on the amount of deposits, so we'll apply different interest rate. So here is the basic idea of this different interest rate ranges. So then we'll need to write a VBA code so that the Excel will tell us automatically what interest rate should apply to this amount of deposit. So for example, 100. So 100 is less than 1,000 here. So this output here should be 5.5%. And here, 1,000 and 100, it falls between this range. So the output should be 6.3%. And so on and so forth. So here, the first question, what is the interest rate for the deposit of $10,000? So $10,000 is actually still within the second range, which is 6.3%. So 6.3% will be the interest rate. Okay, so here, actually, there's some part of the code has been provided already. So let's just go ahead and copy and paste that. Okay, so this is question 2. So this line is basically saying that we don't want minus deposit. So if it's minus, if deposit, that amount is a negative number, then we will just ask Excel to return nothing or error. So if it's a positive number, so starting from 0 to 1,000, then the interest rate should equal to 0.055. So then I can add as many. So remember the if function here, so if statement. So we can add as many else if as we can. And then finally, our final condition should be else. So following the else, no more else if can be added. Okay, so we can only follow else by end if. Okay, so I'll just copy and paste this code here. Basically, we need 2 more. So if it's less than 10,000, so it's 10,000, and it should be 6.3. The next is if it's less than 100,000. And it should be 7.3. And finally, I'll just need one more else. Okay, so finally 7.8% if it's greater than 100,000. And I'll just end if. so let me just make sure everything is correct here. So less than 0, so output error. Less or equals to 1,000, output 5.5%. Less or equals to 10,000, output 6.3%. Less or equals to 100,000, output 7.3%. If it's greater, then output 7.8%. And end if end function. So now let's just input this interest, and it is here. Okay, and it outputs error because this is a -1, which is a negative number. Okay, so perfect. That's question 2. Let's move on to question 3. So for question 3, we need to base on the code of question 2. So question 3 actually requires us to calculate the future value or discounted value. So here we will implement a function called new DFV. The function will return the value, the future value of a deposit with the bank, assuming the deposit and accrued interest is reinvested for a given number of years. So it is asking us to calculate the future value. So if you remember the function for calculating future value, so basically that will be future value equals to some payment today times 1 plus the interest rate, raise it to the power of n period. Okay, so here we need to know interest rate, and the interest rate will be given by this range. Okay, by this range. So therefore, here in this function, we need to let Excel know the amount of the deposit and the number of years. So this is the deposit number in the calculation. This is a deposit number in the calculation, and this is the year. So 10 is the year, and we have this this part 1 plus the interest rate. Okay, and we'll use this interest rate function, which we built in the previous step in our Excel worksheet. Okay, if you have not completed question 2, Excel wouldn't know what you are calling here. So let's go ahead and work on it. So basically, again, copy and paste. I'll need these two here. And it looks pretty nice to me. Okay, so this is actually calculating the future value, and the future value equation is given by things here. And what's new here is actually, we built this interest rate function in the previous step, and we can directly use it in the following step. So now let's move on to question 4. For question 4, here I want you to use to call an Excel function in the VBA. So Excel function is some function like here, the present value function, which will work in the Excel spreadsheet. It will not automatically work in the VBA unless we are using this function here. So now let's go ahead and implement this in Excel. And here what's going on in this question is basically we try to calculate the bond price. And we can actually use the formula to calculate the bond price, and the formula is here. But it will be a little bit complicated to implement this because we have semi-annual coupon payment, and we need to divide the face value by 2 and apply the coupon rate. So basically, coupon rate times the face value will be the annual coupon payment, and this annual coupon payment will be paid by semi-annually. And then the number of period for receiving the payment will be therefore twice of the number of years. And the R here will be also a semi-annual interest rate. So we'll need to use yield to maturity. So the yield is always measured in the annual number. So yield to maturity divided by 2. So that's why when we are using this PV function here, it looks so complicated. So what's going on here is PV, we first calculate the first term here. So the rate will be the yield to maturity B3 divided by the compounding period per year, which is 2, because the payment will be paid semi-annually. So that will be 2% divided by 2. So that is the correct rate. And number of period here will be 2 times number of years, which is 7. So that will be 14 payments. So overall 14 payments. And what is the number? What is the amount of the payment? So that will be, we add a minus sign here, because otherwise if we exclude it, that will return us a negative value, and that is not correct in this case, because later on we're going to add the second term here. So it should have a negative sign here. And the payment will be the coupon divided by 2. So this is the coupon. So B6 is the face value, B2 is the coupon rate. Coupon rate is, again, it's annual rate. So this will be the annual coupon payment, and it will be paid semi-annually, so divided by 2. So each time it will be paid by $15. So, and then here, so that up to this point, we use present value to calculate the first term. And here, the second term will be just using, the discounted cash flow method. So basically, we discount the face value, which is B6, by the discount factor here. And the discount factor, again, we should adjust it for the, the frequency. So R here should be divided by 2, and the number of period here should multiply the year by 2. So enter, that will be $1,065. And we'll implement this in VBA. So basically calling this function in VBA. So let's go ahead and start it. Okay, so I'll use this to call the function PV. Okay, and the next step will be just implementing the formula which we inputted here. So first is the rate, so which is the coupon rate divided by the compounded frequency. Second one will be the number of period. The third term will be the payment, so I should add a minus sign here, bracket. That should be coupon rate times face value divided by compound frequency. Finally, I close the bracket plus second term, face value divided by here is 1 plus yield to maturity divided by compound frequency. And here it should be the number of years times compound frequency. Okay, and it looks pretty good here. And let's go ahead and try in Excel. So coupon rate yield to maturity, time to maturity, compounding frequency, base value, enter. Okay, so let's check if there is any error here. It does not equals to each other, so let me double check. So we have yield to maturity. I see. This should not be the coupon rate. Should be the yield to maturity. Okay, so that's it for this question. So let me further show you the complete formula. Okay, there we go. So now let's move on to question 5. So question 5 is actually can also be built on the previous examples. So the example here basically shows us how to write a loop. So here we have 4 different ways of writing the loop, and 4 different ways will all give us the same result for this question of calculating this function here. Basically, we want to calculate the product of all numbers from 1 to n. And the difference between all of these loops statement is here. This is top checking. This one is bottom checking. This one is top checking. This one is bottom checking. And then the difference between while and until has been shown here. So while is our condition satisfied while I is less or equals to n. Our condition is satisfied while I is less or equals to n. So stop if I is greater than n. So then for this question here, we're going to use do loop until. So do loop until is shown here. So I will just use the bottom checking loop. So do ... loop until. So we can copy and paste the code here when we are using loop ... while statement. So basically, I will just need to change while to until. So what's going on here is here. So if the input function if the n here is equals to, let's say 5, so this one, if 5 is not less than 2, so it will not go to the apple will not equals to 1. It will go to this part here because this condition is false. So then it goes to else. So all the way to this part. So first define I equals to 1, j equals to 1, and then we'll start our loop. So j equals j times I. So 1 times 1, and the new j will be 1. So I here equals to I plus 1. So 1 plus 1. So the new I will be 2. So the new j is still 1, new I is 2. In this case, so the 2 here is still less than 5. So our loop will not stop. And our loop will stop until we have reached a number equals to 6. Okay, so we'll have 1 times 1 times 2 times 3 times 4 times 5. And then this will give us this number for j. So the product from 1 to 5. So let's try this here. So equals. Okay, let's see, and the answer is correct. So let's move on to question 6. Now let's look at question 6. So question 6 is actually asking us to write the function to calculate present value using the for loop statement. So the for loop statement, basically we want to start from I equals to 1 and then to n. And in this case, we know the number of times to repeat this loop. And step here actually shows us whether we want to jump from, for example, the incremental amounts that we're trying to add to this I. So the default will be 1. So actually in this case, step 1 can be dropped. However, if we want to go from 1 to 3 and then to 5 and to 7, so we can write step 2 here. So each time we'll add 2 to I. So the next number, so the first number I equals to 1. So the next number is I equals to 1 plus 2. That would be 3. Okay, that is the idea of adding this step here. So in this case, it doesn't bother to us. We want to increase 1 by every loop. So here, let me just start with this simple code here. So I will just write my code based on the example here of this for loop statement. So to calculate present value, if n equals to a negative number, it wouldn't make any sense. So here I will just require this to 0. So n should not be less or equals to 0 here. If it's less or equals to 0, if it's true, the statement is true, I will ask Excel to return the error. So we have an error function that we can call, which is here. And then we can start our code for the loop. So the loop is actually, we want Excel to calculate the summation from period 1 to period n. So we'll ask Excel, so from period 1 to period n, calculate cash flow divided by the discount factor. So we want plus here. So if you can see here, if we change all the times to a plus, that will be n plus n minus 1 and up to 2n1. And here, similar here, we want this logic, but we just need to change n to cash flow divided by 1 plus r. So what I did is I changed the multiple to plus, and here I will change this to cash flow divided by 1 plus r, raise it to the power of I. So now another thing is the starting point. So the starting point here, if I equals to 1, and j here will be equals to 1, 2. And that will not make any sense because we don't have 1 here. So the first term is directly CF divided by 1 plus R. And the second term will be the first term plus the second term. So j here, actually, the starting point should be 0. And then output will be equals to j. Okay, it looks pretty nice here. Let me just clear this. And equals PV, enter. And it gives us exactly the same number as we use the Excel's present value function.